one root of the equation x squared plus bx plus q is equal to 0 is n times the other root. So n cannot be 0. So that's some information we're given about the roots of this problem, of this equation, quadratic equation. There'll be two roots. One of them is a factor bigger than the other, right? It could be twice as big, it could be 10 times as big. In this case, it's n times as big. And so using that information, we need to then show that this equation must be true, right? So we're given a fact, stands there, and using that, we need to then work towards this, right? We're showing that. So what are the roots of this equation? Let's start there. So we have a p and a q, right? So some unknown constants, which tells me we can't just use our calculator, sadly. In this case, using the quadratic formula would be the most reliable way to do it, where a is 1, b is p, and c is q. And so the quadratic formula, which is in our data booklet, thankfully, the roots would be negative b, so negative p, plus or minus the square root of b squared, p squared, minus 4 times a, which is 1, times c, which is q. That's all over 2 times a, which is 2 times 1. Which simplifies a bit. Minus p plus or minus p squared minus 4q, the square root of that, over 2. So those are our two solutions, right? And you may be thinking, well, that's only one solution. Well, don't forget plus or minus. So we have one solution as minus p plus square root of p squared minus 4q over 2a, or 2, just 2, yep. Or the other solution, which is minus p minus the square root of p squared minus 4q over 2. Right, those are our two solutions. And we're saying that one of the solutions is not twice that, is n times the other. So it's arbitrary which one we pick. For this case, I will pick the negative solution. Well, we don't know that it's negative, but the one with the negative sign in front of the square root is n times the other solution. Right, so one solution, another solution, which is n times to get the other solution. So again, just to recap, we use the quadratic formula to find the roots. We then multiply 1 by n, because that is using this information. So this solution is n times as big as that. In other words, this is the smaller solution. We need to times it by n to get the bigger solution. Great, so now we have an equation. So we use that information after finding the roots. And now we need to try manipulate it to this form. First off, I see denominators, right, dividing by 2. So we could just multiply both sides by 2 to eliminate the denominator. And remember, this n is times, so it's technically in the numerator. We could write it like that. Right, so that'll still, and it's good to write it like that because it's clear that it's n times this whole numerator, not just n minus p, right? It's times. All right. This is already looking closer to what we're after. I notice there's no square root expression there, so we should be thinking about how to square it. If we squared it now, it will get a bit messy. So let's try simplify it so that we have only one square root, or all the square roots on one side in a fraction, and then we square it. So let's expand the right side with the n. So n times minus p minus np minus n p squared minus 4q. Great. Now I will add p to both sides, right, to get that over there. I will add this expression to both sides, so all the square roots are on one side. P squared minus 4q square root. And again, I'm adding this to both sides, plus n p squared minus 4q square root equals minus np, and I added p, there we go. Now on the left hand side we see that square root is repeated, that term, so we can actually factorize that. So we could write p squared minus 4q, and then we're left with 1 plus n equals, and on the right side we might as well factorize this too, p minus n plus 1. Now we can divide both sides by 1 plus n. So p squared minus 4q square root equals p minus n plus 1 over 1 plus n. And so we wanted to get down to here so that when we square it, we just eliminate the square root symbol and there's no other complications. So let's square both sides, and we're left with p squared minus 4q equals p squared minus n plus 1 squared over 1 plus n all squared. Now from here, we're just manipulating it to get to that form. So we could times both sides by 1 plus n squared. And now it's the long grind of expanding and grouping like terms. So I'll just go through this as quick as I can. So we have 1 plus 2n plus n squared p squared Now we can group like terms. So I see a p squared on both sides, so they will be eliminated. Let's take everything to the left side and put the n squareds first. So that's n squared p squared minus 4n squared q minus n squared p squared. And then the n's, so 2n p squared minus 8n q plus 2n p squared minus 4q, 0. N squared p squared minus n squared p squared cancels. Does anything else cancel? 2np squared plus 2np squared is 4np squared. I see a factor of 4 in all of those, so we'll divide by 4. Actually, looking at the problem, the qn squared is a positive, so I'm going to divide by negative 4 to give us n squared q minus np squared plus 2nq plus q. It's looking good now. The only thing left is for the n term to factorize that. So we have q n squared, just rewriting the order, plus 2q minus p squared times n. Right, so we expand that out to get back where we started, plus q equals 0. Oof. Man, I need a nap after that one. Might be a quick way to do it. That's just how I would do it. Yeah, if you found a faster way, do let me know. But to summarize this one, it is an excellence question, of course. So we had a quadratic equation, we found the roots, we then used the fact that one is n times the other to form this equation. And then from there, we used our algebra skills to boil it down to show that this equation is true.